Hello students. Till now in the last class we have discussed little bit chemical properties of the group 17 element. That means mainly about the halogen. Okay. We have discussed up to the stability of oxide. Okay. Stability of oxide. Now we are going to discuss little bit about the uses of oxide. Okay. First one C. This one Cl2O. Okay, Cl2O, that means oxide of chlorine. Oxide of chlorine is used as a bleaching agent in different type of industries, and the industries are suppose paper industry, textile industry. Okay, this one is a very important uses of Cl2O. Next one, see, suppose oxide of iodine. Okay, I2O5. I2O5 is used as the is used in determination of carbon monoxide. Okay, determination of carbon monoxide we can carry it out with the help of this one, oxide of iodine. Okay, next, see how the halogens react with different type of metal. Okay, see, reactivity towards metal. That means how metal react with halogen. Metal react with halogen in some many different ways. Suppose due to the monovalent nature of halogen, monovalent means suppose this one X is a halogen. 1 minus, no, that's why it can form only one bond in normal cases. Okay, that's why usually halogen act as a monovalent. If it is monovalent, then obviously the monovalent metal should come, no? Metal should be monovalent. Remember this one. This is not the what to say, fixed case. This is not the fixed condition or fixed case. The divalent or trivalent metal also can react with halogen, but usually it is observed that monovalent reacts are in something proper way, or you can say something easy way with the halogens. That's why we can observe this type of compound. Suppose NaCl, NaF, KCl. These are, see, this one is monovalent, this one also monovalent, all right. But this type of compound also exists like MgCl2. Here it is divalent. Okay, it is 1 minus, 2 chlorine is 2 minus, that's why. Another example is there, AlCl3. 3 chlorine atom attached with chlorine. Here it is plus 3 minus, that means 3 minus, this way. Okay, now we are discussing about the compounds of metal and halogen. Okay, now see. When the concept of compound of metal and halogen comes, one property should comes. Okay, the property is the ionic character of the compound. Now see. First is the ionic character. Okay, now I am writing some examples. Suppose metal fluoride. M means metal, which is monovalent, and F the fluoride. Okay, next is a, suppose metal chloride, metal bromide, metal iodide. as we are going from metal fluoride to metal iodide, their ionic property decreases. Their ionic property decreases. That means this way covalent character increases, ionic character decreases. Covalent character, and this way ionic character. Ionic character decreases. Why? What is the reason? According to Fazan's rule, said that as the anion size is bigger, or you can say increases, their polarizing power also increases. Okay, that means this one is very large now, this one is a little bit small, this one another small, this one is very small. As the size increases of the anions, their polarizing power increases, and as the polarizing power increases, their covalent character increases. That's why metal iodide is the most covalent and metal fluoride is the least covalent. Conversely, you can say metal iodide is the least ionic and metal fluoride is the most ionic. Isn't it? Okay. This is the reason. Okay. Now see the another example. See. We are discussing covalent character. This one. Suppose we are taking an example. SnCl4, PbCl4, antimony Cl5 and UF6. Okay. So U means uranium. Now this one are the polyvalent metal compound reacting with different type of halogen. Now same type of halogen react with same type of metal, but their valency is different. Now we are writing same type of compound with different valencies. Okay. Now see. Suppose SnCl2. Here it is PbCl2. Here it is antimony Cl3. Here it is UF4. Now see. This one is Cl4, this one is Cl2. That means we can say now, here the team Sn atom is +4 oxidation state. Here it is +2 oxidation state. Here also it is +4. Here it is +2. Here it is +5. Here it is +3. Okay. Here it is 6+. Here it is 4+. Now see, as the charges, that means positive charges here is more in the upper atoms. Okay, but the lower atom has the lower oxidation state. That means these atoms, we are dealing with this metal atom. Okay, this metal atom has the higher polarizing power. That's why these are what? These are little bit covalent nature, but these are ionic nature. Why? Because of the higher oxidation state, they has higher polarizing power, so that they behave as a somehow covalent character, and due to the lower oxidation state, their polarizing power is low. That's why they behave as a ionic compound. Okay. Now see the next point. Next point. Next point is the interhalogen compounds. Interhalogens. That means a compound in between the halogen atoms. These compounds are mainly represented as XX dash. Okay, it may be XX dash, it may be XX dash 3, it may be XX dash 5, this way. Okay. Now this X should be bigger in size, large size, and the X molecule should be smaller in size. Why? the main question comes what? See, this X-tex halogen is accommodated with the or linked with the this X atom. X is another halogen. Now, in case of it is 3 X-tex halogen is attached with the this X halogen, 5 X-tex attached with this halogen. If this X, this one X becomes smaller, okay, if it is small atom, then how they accommodate 3 or 5 number of another halogen atom? That's why this X should be bigger. Another concept is, if these X-tex are bigger, then how they linked, how they attached with the this halogen atom? That's why it should be smaller, it should be bigger. Okay, some examples are, I'm writing examples are, suppose examples are BrCl3. Second example, suppose IF5. Okay, ICl5. These are the examples. Okay. Up to now, we have discussed the chemical properties of halogens. Okay.